I'm Alex. We'll see everyone here. I'm going to talk about Docker and RedHat and what we're doing and why we're doing it. And I am a RedHat developer since forever. I'm actually not a DevOps guy, so sorry. I'm actually a GNOME developer, desktop group at RedHat since 2000. I do zlib, GTK, GNOME Stack, Nautilus, all that stuff. But I also have an interest in application development, application deployment. Actually, my interest is historically in desktop app building, which is actually kind of similar to Docker, which is why I got very interested when we got involved in Docker at RedHat. So why would we be interested in Docker? Well, a lot of people want to run Docker containers on RHEL, and CentOS, and Fedora, and whatever is available in their clouds and whatnot. Not everyone has or wants to run Ubuntu, which is what most people running Docker right now uses. It's also kind of cool technology that we want to have all that Fedora people want able to run. And also OpenShift. I don't know how many you know what OpenShift is, but it's a cloud thing, and it uses something called Gears, which is kind of similar to containers, but it's way less flexible than Docker. And we're looking at trying to use the Docker technologies, or maybe Docker as is, for being able to be more flexible in what OpenShift Gears does. Right now, they're only ever running like whatever is on the host system and then your own configuration and stuff. Recently, what I've been mostly involved with is just getting Docker to work at all in Fedora. Because while Fedora has most of the technology needed, like the namespaces and C groups and that, Docker uses something called AUFS, which is a kernel patch, basically, that adds a union file system. And it is not in the upstream Linux kernel, therefore not Fedora or RHEL, because we're very careful about not adding lots of patches. And also, while it is in the Ubuntu kernel, they're deprecating it, so it's just a question of time before not even Ubuntu has it. So technically, it's not viable in the long term, right? But Docker really needs copy and write. That's basically why they're using UFS. Because to start a container implies cloning your image, basically. And if you do that by copying, it would not be milliseconds, it would be seconds or more. And we need some kind of copy and write technology. And the kernel actually has several technologies that involve copy and write. Overlay FS it's actually another out of upstream patch for union mounts, but it is the one that is currently most likely to eventually reach upstream inclusion. I think it's great that we finally may get something, but it's not something that exists right now, and it's not something we can rely on right now. There's also BufferFS. It has two kinds of copy and write. You can use subvolumes and do snapshotting of them, and you can also, there's a copied file operation called reflink, which basically copies the file, sharing all the back pointers to the original data blocks. But BufferFS it's cool technology, but I wouldn't call it production ready right now. And if you talk to the file system people at RedHat, they're like, yeah, not really. It's gonna be, I don't know, a couple of years or something before that's deployable, I guess. LVM, which is the logical volume manager, does copy and write snapshotting, but this is at the block level. So basically, you snapshot the entire file system. There are two versions of it. The original LVM snapshots are unfortunately a poor match because they're really slow. Every time you do a snapshot, it will cause the other snapshots to linearly grow in slowness. But there's a new version of it called thin provisioning, which is you can do as deep as many amount of snapshotting in row, and it does not affect performance in any way. So that's, I think, currently the only technology that can work for this. So that's what I started to implement in Docker. It's actually, I mean, I'm saying LVM, just a logical volume manager, but it's really only using the device mapper side, which is like the kernel part, the kernel module that LVM configures. So I'm not actually using the LVM user space like the command line tool or the config format. It's just bashing on the hardware or on the kernel module support. And also, I don't want to actually have you set up block devices or whatnot. So what Docker will do for you is it sets up these loopback mounts. So there are these files here, data and metadata, which is two fake devices. One is 100 gig and the other one is 2 gig or whatever. But they're not actually that large. They're sparse files, so they start out empty. So they look large, but they're not large on disk. And then we use device mapper to combine these into here's the pool, which has got all that 100 gigs in it. And you can create device instances inside that pool. So basically, the instances are thinly provisioned, meaning that they start out, even though they're a certain size, they start out using none of the blocks from the pool. And as you start using blocks, you pull them from the pool. And you can also do snapshotting of the devices, so they will share blocks until one of them changes one of them. So what we do is we create an energy file system on one of the devices, and then we start from that, where each image is a clone of either the empty device or another image. And when you instantiate a container, you use clone or snapshot one of the image, and that we immediately get 100% block identical file system, and then you start the pushing from there. And then when you commit the container to create a new image, we create a new snapshot from that. There's also something called trim that we enable in all the file system and devices and stuff. That it's typically used for SSDs and stuff, where if the file system deletes, or if you delete a file so the file system knows that certain blocks are no longer used, it would mark them as trimmed, or using the trim command, it would mark it, and the SSD will not reuse those blocks or whatever. But in the case of thin provisioning, it will return those blocks to the pool, and the device mapper will return it will recreate the sparse region in the original loopback file, so you give all the space back to the host file system whenever you delete something inside a container. So this is cool. It works. You can use it on any modern upstream kernel. Basically, every distro available right now has this in it. The thin provisioning stuff is supported as of RHEL 6.4. There's no setup needed in terms of block devices or what have you. And it starts out small and grows as you need more space. But it's also kind of complicated with all this layering of loopback devices and whatnot. And even though it grows, there are certain inherent max limits. Like you start with a certain size of the loopback file, you make a empty file system of a certain size. All these can be kind of grown at runtime. So you can resize the pool without shutting down or something, but it's still something you have to kind of manage manually. Also, you saw the Docker diff command. It is a bit slower on this because you can't actually have an instant. In the Union FS model, whenever you modify a file, it just writes the copy in its own directory where you have all the files that were changed in your layer, whereas here we actually have to compare the file systems. So diff is a bit slower. Also kind of technically complex, but the way page caching works is it's it's keyed off the file system. So even if in the then provisioning model, a file shares the same disk block, they're not actually sharing the same page cache if you have multiple snapshots mounted. So you would not be able to have the same density. In many cases, it doesn't matter if you're running different containers on your app, but if you're OpenShift and you run 1,000 containers all using the same binary, it will use more memory. So I'm thinking long-term overlay FS or whichever union FS we finally get is what we want. But until then, at least we have something that works. We've also been adding Docker to Fedora, meaning the code package. We packaged all the dependencies, various Go libraries and whatnot. We fixed our Go packages to have various fixes, and we have a Docker IO package. It's an unfortunate name because Docker was already taken by some manager thing. but I think we have a plan how to eventually rename it to Docker, but that will take a while to happen. The current package is in Rawhide, which is the rolling release unstable RedHat. It's based on the RC4 snapshot of 07 with the device mapper code. That's the first, basically, release of the device mapper code. Or rather, when 07 is finally released, it will be the first release with it. And by that time, we'll have backports to current and coming Fedora stable releases. Furthermore, we're doing more work inside Docker to have it work better in the RedHat stack, the infrastructure that we use. Like we try to avoid static linking in Fedora and RHEL, rather than linking like Docker currently has dependencies in libdevmapper and SQLite, and we want to have them use the system install versions. So we had to modify Docker to handle that. We're also working on making it optionally use libvirt LXC, which is, I don't know how many people are using libvirt, but it's like the standard API for virtualization management on Red Hat systems. Having Docker use that means you can manage your Docker instances from the standard virt manager and whatnot. But it also gives you some new features like SLM support and more advanced network topologies where you can basically use the existing tools to define your networks and have Docker images use that. We have some initial code available, and we're targeting a 08 release for this, which is we're supposed to do our Docker release every month. So I would say if we release 07 like in 2 weeks, that'd be 1.5 months until 08. But who knows? We've been kind of delayed recently. We also created Fedora images, like you saw in the demo. It's all about Ubuntu. But we now have Fedora images based on Fedora 19 and Fedora 20 release candidates, so you can look at cool piece. So the Fedora is like a 150 meg standard build. There's also a really tiny one that has minimal dependencies. It's built in the Fedora build system using standard cloud tools that we have, so it's an official build in some sense. But we also plan to have Docker in people making an official build so that you don't have to use this prefix. This is how you can register on anyone can register the Docker index and create their own username. You can create whatever image you want under your username. But we want to have it so you can just do Docker full Fedora. And that will happen, I guess, around the 07 release. We're also working in the Fedora Cloud SIG to kind of make Fedora better in the cloud space overall, just by tightening up the dependencies and whatnot. But we're also looking at doing additional builds on certain core packages. Like if your container full set of dependencies is not meant to run a full machine, why would you need firmware? Why would you need UDEV rules? Why would you need like kernel modules and init systems and all that? So if you can optionalize certain dependencies for non-hardware environment, that would be nice. That way we can have the less shit you have in there, the less things can go wrong, right? And generally we will work all with Docker to see if we can fix or improve things. But I think that's what I had to say.
Right. What are the implications for existing AUFS-based
images? We're actually discussing that right now. If you run the RC4, it will auto-convert your existing containers. We're talking about having that not happening. Instead, like having a completely separate set of containers and image, and then you have tools to auto-migrate stuff, so that would make it easier to revert and upgrade, for instance. Not sure exactly what will happen. But if you run the current code, it will auto-migrate all your stuff.
How long do you think it will be until it's possible to install Docker in RedHat or CentOS?
I mean, it is. If you run the RC4 snapshot, it's possible to run in RedHat 6.4. I mean, I've done it, but you would need to add some EPO stuff like the LXC tools and not. But technically, the existing binaries, when we get an 07 release, which should be in at most 2 weeks or so, you should be able to get them running on a 6.4 or so.
Is Ubuntu's target overlay FS as well?
I don't know what the plan is. I think they just realized that AUFS, the maintenance burden of this enormous thing that touches everything and has zero chance going upstream. It's just they'll wait until something happens. I don't think they have any particular. I mean, the reason they have AUFS is that their live CD uses it. So you can boot from the live CD and still have something writable. And I guess WAFS would work for that too.
Yeah, they're actually moving toward FS. It's in the Ubuntu kernel 12.4.
But they're actually using it already.
They were going to deprecate AUFS for 12.4, but then there were some issues, I guess.
There's always some issues.
Are your changes pushed up to Docker? Like anything that's needed for?
Yeah, it's in the branch. It's not landed yet. Some of it has landed. Some of it is in the branch. But we're trying to merge it this week or next week. It's been a bit delayed, but it will happen in a few weeks.
Okay. As I asked before, how do you deploy? I mean, of course you can copy the machines from developers to production.
Well, I mean, you.
That's a demo, but we can.
Yeah, I mean, so Docker isn't anything actually. I mean, we mostly talked about what you'd call the runtime, and you talked a bit about the build system, but also it has something called the index.
Yeah, I know about that, but
so you could have your private index and upload your image there, and then anyone could clone it.
okay, I mean you have your own index.
Yeah.
All right.
So the index server is also open source. You can run that.
All right. Thanks.
When you say we, how many are you working with Docker?
I don't know. I mean, I'm doing most of the work on the device mapper. Josh is doing most of the work on the libvirt stuff. And then we have another guy doing the packaging, and Matt is doing the images, plus various people involved. So I'd say that like 4 people didn't work, and a bunch of people, maybe 4 more. So
I was just reading the .cloud. They're called Docker right now.
Yeah.
Since yesterday, they were writing that I think 50% of their commits are actually not from themselves, and they also wrote that RedHat is a really large contributor to the project.
Yeah, I mean, it's pretty recent, but we've done a lot of work recently. I wouldn't say 50% of their
maybe
for
the last
us,
release or something like that.
yeah,
From the beginning.
I'd say it's the last release maybe, but I mean, historically, it's been an internal project from them, right? That got
Yes.
huge, and they do have a lot of people involved, but I wouldn't say they have